Greetings everyone, and today we are going to discuss about gases. Gases are, we know that there are three states of matter: gas, solid, liquid, gas. Gases are the state of matter which are the simplest form. Solids are the state of matter which is found most in over the planet of Earth. And here we are having gases. Gases are basically having is that state of matter which is found um, in many forms in our on Earth, whether it is in the form of whether it is in the form of air or is it in the form of gas which is required for respiration or photosynthesis. For photosynthesis we require carbon dioxide gas, and for respiration we require oxygen gas. For cooking we require the methane gas, and in industries we require natural gas and other types of gases. Apart from that, when we are utilizing gases as a source of vehicle, a source of a fuel, then for vehicles we are also having a compressed natural gas CNG as an alternative for gasoline. All of these are gases. Now coming to the point that what is the chemical basis of gases? Gases are basically having those particles which are not having a definite shape, not having a definite volume. Why? Because these are not having no intermolecular forces in between them. Why these are not having intermolecular forces in between them? We know that gases are basically, for example, this is a gas particle, this is a gas particle. Gas particles are quite minute, tiny particles, due to which they do have high nuclear force, due to which as a result of the high nuclear force they do not have um, a much amount of reactivity. As they have high nuclear force, they have more stability and less or no reactivity, negligible reactivity, due to which as there is more stability, there is no formation of charges over them. As there is no formation of charges, there are no intermolecular forces existing in between them. So it indicates that there are no intermolecular forces or binding forces in between the gases molecules. One more thing, that gas molecules always exist in the form of molecules, not in the form of uh, atoms or formula unit or compound, such things. So here this is the first reason. And secondly, they are having high kinetic energy because no intermolecular forces or attraction are there. So these are having high kinetic energy. We are going to discuss now the kinetic molecular theory. It was given in 1728 by uh, Daniel Bernoulli, and then it was modified during a long period of time by Boltzmann and Maxwell, as well as by Colsis and Wonderwalls. So, coming to our main point, that what are the postulates of this theory? It is describing that gases are composed of a large number of particles that behave like hard spherical objects in a state of constant random motion. They have a constant random motion. For suppose this is a container, here there is gas. These are the gas particles. Now, gas particles uh, in if there's a single gas molecule, then that moves in a single line, a straight line. But when we are having different gas molecules within the same container, these gas molecules after moving in a straight line at some time collide with the walls of the container, or collide with each other, or they collide with each other, due to which as they collide with each other, they uh, cause to exert uh, their motion in the opposite direction. For suppose if if this molecule is colliding on this gas molecule, then it will change its direction and then move irregularly into another direction. So when we are talking about the net motion of gases, net motion of gases is an irregular motion, or we can also say that this motion is kind of zigzag motion, or random motion, or we can also call it irregular, random, or zigzag motion. And this motion was given by Robert Brown in 1827, due to which it is known as Brownian motion. Apart from that, uh, that motion also gives the basis of elasticity, that these are elastic particles, these are having elastic collision. They are hard spherical objects, apart from which these particles move in a straight line, unlike they until they collide with another particle or the walls of the container. These particles are much smaller than the distance between the particles. These particles are much smaller than the distance between the particles, which means that at low pressure, these particles are smaller. As at low pressure, these particles are smaller. At low pressure, at low pressure, these particles are having their average distance between their molecules greater than the molecular diameter of the molecules. We can also practically prove it. If we are having low pressure and high temperature, then the molecules are far apart. And if molecules are far apart, then the average distance between the molecules is high, and it is higher as compared to the molecular diameter of these molecules, due to which we can say that this condition exists in gases. Now, there is no force of attraction between gas particles or between the particles and walls of the container, because they have high nuclear force, due to which intermolecular forces of attraction or repulsion do not exist. Collision between gas particles or collision with the walls of the container are perfectly elastic. Why these are elastic? Because gas particles are silkish, fluffy, silkish, fluffy, or rubber like particles, which do not cause any harm to the material they are um, to which they are colliding. Apart from that, when they collide with any material, whether it is a solid or gas itself, then they do not lose their kinetic energy or momentum. Apart from that, the average kinetic energy of a collection of gas particles depend on the temperature of the gas and nothing else, which means it does not that the kinetic energy of the gas particle is directly proportional to the absolute temperature in kelvins, and kinetic energy does not depend upon the nature of the gas molecules. For suppose we are having hydrogen gas on one hand side and chlorine gas on another hand side, then although both of these are having different natures, but both if both of these are kept at 300 kelvin 300 kelvin, if chlorine is kept as 300 kelvin and hydrogen is also kept at 300 kelvin, so when hydrogen and chlorine both are kept at 300 kelvin, then both would be having the same kinetic energy regardless of their different natures of gases. Now, assumptions behind the kinetic molecular theory can be illustrated with the apparatus, which is based on the experiment further. So this is all about kinetic molecular theory. Hopefully we'll meet again in the next video with further detail of the topic.